Dear students, in the previous class I have explained you the primary and the secondary batteries. The primary batteries are those which cannot be used up again because they cannot be recharged, and the chemicals when are over or used up, we have to throw it away. The secondary batteries are those batteries which can be recharged and can be used again and again. I also explained you the construction and the working of the dry cell. Today I am taking another example of a primary cell known as mercury cell. It is also commonly known as a button cell. It is used in those devices which need low current. For example, hearing aids, wristwatches or the calculators. Let me explain you the construction of a mercury cell. Since it is an electrochemical cell, so there must be an anode, a cathode and an electrolyte, and obviously there will be the transfer of electrons. The anode here is made up of zinc. The cathode is made up of mercuric oxide and graphite, and the electrolyte is zinc oxide and KOH. The reactions at anode. At anode, we already know that the oxidation takes place. Oxidation means the loss of electrons. Since the anode is made up of zinc, zinc will lose 2 electrons and will oxidize to Zn2 plus state. These 2 electrons are accepted at cathode, and HgO, that is mercuric oxide, is reduced to mercury. Just see the overall reaction. Zn, within the brackets it's Hg, this is known as zinc amalgam, plus HgO solid, and it gives zinc oxide plus Hg. With Hg in the brackets it's written L, small l, that denotes that it is liquid. I hope you all know that mercury is only the liquid metal. In the overall reaction, you see that there is no involvement of any ion whose concentration can change. So, the cell potential of the mercury cell or the button cell is constant. It is a very common question which is normally asked in the exams, that why the cell potential of the button cell remains constant, and its answer is its overall reaction does not involve any ion whose concentration changes. Secondary cells. The example is a lead storage battery. This is the battery we are using in the inverters. It has an anode and cathode. Anode is lead plates and the cathode is a lead grid packed with lead oxide, and the electrolyte is the 38% solution of sulfuric acid. Let me explain you its working. At anode, which is made up of lead, it gets oxidized by losing 2 electrons and it forms Pb2 plus. Pb2 plus combines with the sulfate ions and forms lead sulfate. On the cathode, the 2 electrons which are lost by the anode are gained at cathode. PbO2 is reduced to Pb2 plus form and then it forms lead sulfate. So, lead sulfate gets deposited in the inverter batteries or the lead storage batteries. Slowly, the sulfuric acid is also consumed. Its density decreases. Lead storage battery is a secondary cell. So, it can be recharged by just passing electric current. On passing the electric current, the reactions are reversed. The flow of the electrons is also reversed, and the role of anode and cathode is also reversed. The lead sulfate which was deposited during discharging, now it forms lead and lead oxide, and the chemicals are again refreshed. So, this cycle is repeated again and again. When there is no light or when we are using the battery, the chemicals are used up and that is known as the discharging. But when we are not using it, all the chemicals are recharged. So, we can use the lead storage battery again and again. There is another example of the secondary cell, that is nickel cadmium cell. The nickel cadmium cell is very eco-friendly and very light and compact, but it is expensive. So, normally we don't use it. But if we have to prefer out of this lead storage or nickel cadmium, no doubt nickel cadmium cell is expensive, but since it is eco-friendly, so we must prefer the nickel cadmium cell, keeping in mind the long-term benefits. We must take care of our environment. The next topic is the fuel cell. Again, it is an electrochemical cell. Dear children, in the thermal plants, we know that how the electricity is generated. I hope you know that the fossil fuels are burnt and this energy is used to convert water into high pressure steam. This steam is used to run the turbines and the electricity is produced. The efficiency is very less and it causes pollution. So, nowadays fuel cells are used. In this, we oxidize or we burn some fuel. For example, hydrogen, methanol or methane can be used as fuel, and the oxidizing agent can be used like oxygen we normally use. Today, I will explain you the working and the construction of hydrogen-oxygen fuel cell. This cell was used in Apollo space program. First of all, let us define what is a fuel cell. Cells which convert chemical energy obtained from combustion of fuel directly into electrical energy are known as fuel cells. They are quite efficient and free from pollution. Today's example is a hydrogen-oxygen fuel cell. Here, hydrogen is the fuel. From the diagram, you can see that from one side, the hydrogen is bubbled constantly and from the other side, the oxygen gas is bubbled. The electrodes are made up of porous carbon and the electrolyte is sodium hydroxide. The construction you can see. This is another diagram of the fuel cell which is showing the working and the combination of the hydrogen and oxygen. The byproduct is water. The water vapors are condensed and these vapors, when condensed, the liquid water is used by the astronauts. So, we can say that a fuel cell is very eco-friendly. There is no pollutants are produced. In the hydrogen-oxygen fuel cell, a catalyst is also used, which is normally either platinum or palladium. I hope you all know that the role of the catalyst. It increases the rate of reaction. Details we will study in the next unit, that is chemical kinetics. Now, let me explain the reactions which are taking place at anode and cathode. At anode, hydrogen gas reacts with the hydroxide ions. It loses 4 electrons and the water is formed. These electrons which are lost at anode, they are gained at cathode by oxygen, and these electrons which are lost at the anode are gained at cathode, and oxygen in presence of the water accepts these 4 electrons and hydroxide ions are formed. Overall reaction: 2H2 plus O2 gives water molecule. So, you can see that there is no product is formed which causes pollution. Only the water is formed, and when the fuel cell, this hydrogen oxygen fuel cell, was used in the Apollo space program, the water was used for the drinking purposes by the astronauts. So, dear students, in this unit we studied about the electrochemical phenomena. The electrochemical phenomena in which the electrical energy is produced by the energy which is produced during a spontaneous chemical reaction and is converted into electrical energy. This electric energy is in turn used to carry out non-spontaneous chemical reactions. I also explained you the working of a galvanic cell, the need of a Saul bridge for the continuous working of a galvanic cell, also known as the Daniell cell. Then I explained you how to calculate the cell potential, the standard electrode potential by using the Nernst equation. We also studied about the conductors, the metallic conductors and the electrolytic conductors, that how the metallic conductors are different from the electrolytic conductors. I also explained you the concepts like resistance, conductance, resistivity, conductivity and the molar conductance. Then I explained that how the concentration or the dilution affects the conductivity and molar conductance. And I also explained through the graph. This graph is very important for the examination purpose. You must know how to plot the graph and how to explain the variation of the molar conductance with dilution. Then comes the Kulrash's law. It's very useful law to calculate the limiting molar conductivity of the weak electrolyte which otherwise cannot be found out experimentally. Then we also studied the electrochemical processes taking place in our day-to-day life where we must know that we are using cells and batteries and fuel cell which are based on the electrochemical phenomena. We also studied the hydrogen-oxygen fuel cell. I hope all the topics are clear to you.